These are the notes for Algebra 2. We're going to be dealing with factoring, starting with GCFs, or greatest common factors. And before we get started, there are a few vocabulary terms that we need to be aware of. The first is factoring. Well, in algebra, factoring is finding what to multiply together to make an expression. Now, an expression can be a single number, and then factoring is finding what two numbers you'd need to multiply to get to those numbers. For instance, if I wanted to find the factors of 6, well, the numbers that I would multiply together to get 6 would be 3 and 2. So 3 and 2 are factors of 6. Now, that's a concept that we're familiar with. We've seen it before. You might have also seen greatest common factor, or GCF. The greatest common factor is the largest factor that all the terms in an expression share. So, then whatever the greatest common factor is must be a factor of each term in the expression for it to work. The last one is a polynomial, and a polynomial is it's an expression that's usually made up of several different terms being added or subtracted. Alright, so those are our basic vocabulary. Now let's look at using greatest common factors, GCFs, to factor a polynomial. For instance, in example 1, I want to factor 15m squared minus 9. Now, the process that I do this is fairly straightforward. I want to look at both of my terms, and I have two. I have 15m squared, and I have negative 9. Two different terms. I look at both of my terms, and I try and figure out what the largest factor they both share is. Now, 15, I can divide by 3, and I can divide it by 5. 9, I can divide by 3. So they both share a 3. This is a lot like reducing a fraction. Since they both share a 3, that is the largest term that they both share. 9 doesn't share the factor of 5, so they don't share anything bigger than 3. Now the first term has an m squared in it, but the second term doesn't, so they do not both share an m term. Only the first term has one, so we can't list that as part of it. Therefore, the largest factor that both terms share is just 3. Now, the next thing we want to do is take the 3 that we know both terms share and divide each of your terms by 3. So, I'll divide 15m squared by 3, and I will get 15 divided by 3 is 5m squared. Negative 9 divided by 3 is negative 3. So once I've divided both of my terms by the largest factor, the greatest common factor, I get 5m squared minus 3. Now I'm not quite done. I have 5m squared minus 3 in parentheses. Outside of the parentheses, I'm going to put the 3. So I have 3 times 5m squared minus 3. Now what you might notice here is that this looks like something you would distribute. And in fact, if we distributed the 3 to the 5m squared and the 3 to the negative 3, we would end up with 15m squared minus 9. So in that way, factoring with a greatest common factor is a backwards version of distribution. We are in fact distributing in reverse. Let's look at a different example here. Now this time we have 3 terms. 4x to the 5th, negative 6x. I'm just going to put symbols around here so I can keep it straight. Negative 6x to the 3rd, and 14x. 4 times x to the 5th is one term, negative 6x to the 3rd is another, and 14x is a third. So I look at my terms and I decide, all right, what is the largest factor that they both share? Well, 4 can be divided by 2, 6 can be divided by 3 or 2, and 14 can be divided by 7 or 2. So the largest number that they all share as factors is 2. So I'm going to put 2 here. I can divide all three of these terms by 2. But you'll also notice that they all share this x term. I have x to the 5th, x to the 3rd, and x. That means that x is also a factor of these three terms. And when I look at that, I say, okay, x is also a factor. What's the largest exponent that is a factor? I have an exponent of 5, I have an exponent of 3, and I have an exponent of 1. No exponent is an understood exponent of 1. Therefore, the largest exponent that I share here is x to the 1st. That means I will just put an x here, x to the 1st. If they had all shared a squared, then I would have put x squared. Now again, I see that the largest factor I've got going on here is 2x. So I'm going to divide each of my terms by 2x. Now we haven't dealt with dividing exponents, but you have seen it before, and we're going to use that. When I divide 4x to the 5th by 2x, 4 divided by 2 is 2. X to the 5th divided by x is x to the 4th, because when we divide something to the 5th power by that term to the 1st power, we subtract the exponents, and we get x to the 4th. Negative 6 divided by 2 is negative 3. X to the 3rd divided by x is x squared, because 3 minus 1 is 2. 14 divided by 2 is 7. And x to the 1st divided by x just goes away. Right? And x on the top of a fraction and on the bottom of a fraction would cancel each other out. So the last term is just 7. Now again, I'm not quite done. I need to take the largest factor, the GCF here, and put it out front. So I have 2x times 2x to the 4th minus 2x squared plus 7. And again, if I were to distribute this 2x back into this polynomial, I would end up exactly where I started. All right, we're going to look at one last example here. A little bit more complicated now, but still perfectly doable. Again, we want to find the largest factor. This says both. Should be all. The largest factor that all the terms share. Actually, in this case, it should be both, shouldn't it? There are only 2. There are so many of them there that there are only 2 terms that they both share. Now, I have a 15 and I have a 20. Well, 15 is divisible by 3 and by 5. 20 is divisible by 4 and by 5. So they both share that factor of 5. So 5 is going to be one of my shared factors. Now I have an x term in each, I have a y term in each, and I have a z term in each. So I need to look at each letter individually to decide what is part of my GCF. X to the 3rd, x squared. Well, x to the 3rd is x squared times x. Right? X to the 3rd contains x squared. Therefore, both of these terms share x squared. Y squared and y. Now, that one we've seen before. Y squared contains y because y squared is y times y. So, they both share a y. Now, I have z and z squared. Well, z squared is z times z. So, they both share z. That means that my largest term that all of these share, the GCF, is 5x squared yz. And I'm going to start this time by writing that out front. 5x squared yz. Now, again, I'm going to divide each one of my terms by 5x squared yz. 15 divided by 5 is 3. X to the third divided by x squared is 3 minus 2 is 1. So x to the first, or just x. Again, x to the third divided by x squared is just x. Y squared divided by y is just y. And z divided by z cancels out. So there is not going to be a z term in this first item here. We move on to the second one. We have 20 divided by 5 is 4. X squared divided by x squared cancels out. Right? When you divide something by itself, it cancels out. Y divided by y, again, cancels out. And z squared divided by z is just z. So I end up with 5x squared yz as my greatest common factor outside the parentheses. And inside the parentheses, 3xy plus 4z. And if I distributed the 5x squared yz back in, I would end up with what I started with. Alright, now I want you to complete the problems, the checkpoint problems on your notes, and bring the completed problems to class. Remember to find the greatest common factor that all of the terms share.